Okay, what we have here is an AC circuit based on the Donald L. Smith's work. Uh, we do have one diode in the circuit. We'll show you that in a minute. That's at the light assembly. But the coils and capacitors are fired off of a 6,000 volt neon transformer. As far as lights go, we've got two lights running off of the spark gap assembly. And we have 10 new ones here hanging in the closet. This is a GTO wire here for the neon, and the copper screen wrapped around the exterior. That goes to actually earth ground. And this is the D1 diode we're going to show you here in a minute. And as far as frequency goes, that's kilohertz, by the way. That's the voltage and frequency. This is off the spark gap. This is one of the coils that picks up the explosions in the spark gap. This is on the ceramic tip. And the blueprint right here looks familiar. This is the variac. This is an isolation transformer. This is the 6025-SEG-U. This is a transformer, 6,000 volts, 25 milliamps. We have a impedance matching capacitor here, which happens to be about 2.7 nanofarads at 90 kilovolts. Spark gap, we're extracting some of the energy out of the spark gap based on the Ed Gray's work. Two fluorescent tubes going right to earth ground. This is C1 is 0.047 microfarads at 10 kilovolts. This is the isolation transformer, high voltage, radio frequency, resonant frequency, and it's adjustable with a ferrite core inside, or we can take it out and have an air core for higher frequencies. Two 49 volt windings, center tapped. Center tap is connected to the bottom one. It's going nowhere. This is an open circuit for environmental energy to come into the circuit, so it's an open circuit. D1 diode we just showed you here, microwave oven diode, and we've got 10 lights going right to earth ground. And let's get some more readings here. You can see the spikes, high voltage spikes. This waveform is unique to this circuit. A lot of this started happening after we put all 10 of those lights in with that new GTO wire with the ground wrapped around it. So basically that's it's a capacitive circuit with induction. It's not sure what the impedance of that thing is, but it definitely affected the circuit and affected this waveform. Let's go inside here and see if we can see the temperature of the spark gap. This thing runs very cold. Yeah, it's running about 80 degrees here, less than 80. Let's see if we can get that thing to focus. Here we go. 80 degrees. This is the CM capacitor here for the impedance match. And spark gap, I can't see it real well. It's about 100 thousandths gap on here. And the voltage and the frequency we were picking up is coming off the spark gap right here. This is a coil wrapped around that piece on the end. It's a TIG welding tip, ceramic. So there you have it.